Okay, so again, we just need to check and make sure that these two matrices have the same dimensions. So the first one has 2 rows and 3 columns. Second one also has 2 rows and 3 columns. Okay, so then all you have to do is subtract the corresponding elements. So we have 1 minus 6, 9 minus -2, and 5 minus 0 in the first row. In the second row, we have 2 minus 1, -4 minus 1, and 3 minus 8. Okay, 1 minus 6 is -5. 9 minus -2 is the same as 9 plus 2, which is 11. 5 minus 0 is 5. 2 minus 1 is 1. -4 minus 1 is -5. And 3 minus 8 is -5. That's our answer. Any questions so far?
Is there a possibility you can maybe kind of get up there on maybe 1, 2,
I'm sweating up here.
I'm literally shivering in my seat.
Sorry. Like, I was thinking about opening this door, but I won't do that. That'll be my compromise. Okay, we got one more. Well, before we move on to multiplying matrices together, first, we're going to look at okay, so we're going to take 2/3 times this matrix. So some number being multiplied by a matrix. Okay. All we have to do is distribute whatever this number is to each element in the matrix. So this becomes 2/3 times 18, 2/3 times 24, 2/3 times 9, and 2/3 times 12. So each number in the matrix gets multiplied by whatever number's on the outside. Okay, 2/3 of 18 is 12. 2/3 of 24 is 16. 2/3 of 9 is 6. And 2/3 of 12 is 8. Okay, so that is addition, subtraction, and multiplying by a number. Those are all fairly simple. What we're going to look at next is a little bit more complicated, but it's nowhere near as complicated as solving systems of equations was. Matrix multiplication.
What was the top thing called again?
matrix operations. Hold on. Okay, I'm gonna give you guys a second to copy.
What is the last word of the first sentence there?
Calculated. Okay, suppose matrix A is 3 by 2 and matrix B is 2 by 4. Can the product A times B be calculated? And if so, what is the size of the product? So to be able to add or subtract matrices, we know that we had to have the same size. These dimensions are not the same, but when you're multiplying two matrices together, they don't have to be the same. Here is what you have to look at when you're multiplying two matrices together. So we have matrix A, that is a 3 by 2 matrix. And matrix B is a 2 by 4. And since we're multiplying A times B, we write them in this order. A comes first and then B. So when you write the dimensions, the two numbers on the inside have to match. So since these two numbers do match, they both have 2's on the inside, that means that we can multiply A times B. So the answer to this question, can the product A times B be calculated? The answer is yes. Then it asks, what is the size of the product? The outside numbers of these dimensions gives you the dimensions of the product.
Me too, bro. I cannot.
I'm writing a little bit small with this part.
Oh, that works.
A little better. So yes, we can multiply A times B, and our answer is going to be a 3 by 4 matrix. Okay, next question. Can the product B times A be calculated? So we switch the order. Instead of A times B, now we're looking at B times A. I'll give you a second.
Okay, what was the answer for the first one? I know it was yes, but like what was the explanation?
The dimensions of the answer are going to be a 3 by 4. I just put 3 by 4 under yes.
What A's and U's look exactly?
Okay, so our matrix B is a 2 by 4. Matrix A is a 3 by 2. We have to write it in that order because that's what's being asked is B times A. So when we write it like this, the inside numbers have to match. And they don't match. So our answer is no. We can't multiply B times A. So it's different from just normal multiplication because normally with multiplication, you can multiply in any order. It doesn't matter. Like 2 times 4 is the same thing as 4 times 2. But with matrices, it's different. If you're trying to multiply two matrices together, the order matters and the inside numbers of the dimensions have to match. Okay, I'm gonna try to shorthand this. There's like, let me explain this to you guys. I'm not gonna make you write it all, but if you know, the way that we write dimensions of a matrix is rows times columns. So if this is matrix A and it's got some number of rows times some number of columns, sorry, rows times columns for matrix B. So what we're saying in the two examples that we worked is that the number of columns in the first matrix has to match the number of rows in the second matrix. So those have to match. And then the number of rows in matrix A and the number of columns in matrix B, that's going to be your dimensions of your product. Okay, let's do some examples. Okay, so before we try to multiply these matrices, we have to make sure that we can. So let's look at the dimensions of both of them. The first matrix has 2 rows and 2 columns, so it's a 2 by 2 matrix. The second matrix has 2 rows and 4 columns. So all we need to be able to work this is for these two inside numbers to match, and they do. Okay, so the way that we multiply two matrices together is we use what is called a product sum. Product sum. So a product is what you get when you multiply. A sum is what you get when you add. So we're going to be doing both of those in order to multiply these matrices together. Okay. So we know that our product matrix is just going to have 2 rows because that's what our first matrix has, but it's going to have 4 columns like our second matrix. So it's going to be a 2 by 4 matrix just like this. Okay, so if I want to know what number is supposed to go in this first position, this first row, first column position of our product, we're going to use the first row and first column of our 2 matrices. So I don't want you guys to scribble up your paper. I want you to be able to see your paper later, but I'm going to do it on mine so that you guys can see what I'm talking about. So I'm wondering what number goes in this position, which is the first row, first column of this matrix. So I'm going to use the first row of the first matrix and the first column of the second matrix. First row, first column. And I'm going to do what is called a product sum. So we take the first 2 numbers in that row and column, which would be a 1 and a 1, and we multiply 1 times 1. Then we take the second 2 numbers, -3 and 3, and we multiply those together, -3 times 3. And we add those products together. So we took the first row and first column, and we did 1 times 1, and we did -3 times 3, and we added those together. That's how we're going to get the number that goes in the first row, first column of our answer. Okay, so let's look at if we were going to move on. We're going to stay in the first row, but I want to know what number goes in the first row, second column. So we're still using this first row from our first matrix, but now we're going to use the second column in the second matrix. So first row, second column, which is what this position is in our answer. So ignoring this row, we're doing multiply the first 2 numbers, which would be 1 and 0. So 1 times 0 and -3 times 1, and we're going to add those together. So 1 times 0 plus -3 times 1. Oof, I'm going to run out of room.
This one with guys or sure?
Yes. Okay, sorry. I was running out of room, so I'm going to move my answer down below. Okay, so now we're still in the first row, but we want to know what goes in the third column of our first row. So first row, third column are the numbers that we're using now. So it's going to be 1 times -1 plus -3 times 4. First row, fourth column. So we're still using 1 and -3, the first row, but now we're using the fourth column of our second matrix. 1 times 2 plus -3 times -1. Okay, before we move on to the second row, I want you guys to notice a pattern that's going to hopefully make things easier for you. In that entire first row, we used the 1 and -3 from the first row of this first matrix. So if we look at our product sums, we have 1 and -3, 1 and -3, 1 and -3, 1 and -3, because we use the first row for every one of those product sums. We use 1 and -3. That's going to be true for the second row as well, except this time we're using the numbers that are in the second row, which is 7 and 2. So let's go ahead and just fill those in, leave spaces. So this is going to be 7 and 2. For everyone, I'm just moving down, writing right below where 1 and -3 is for each one of these product sums. In the second row, we're going to have 7 and 2. Whoops. Okay, now, if we're looking in the second row, first column, we've got 7 and 2, which came from the second row here. And then we need our other numbers to come from the first column of this matrix. So it's going to be 1 and 3. Okay, if you compare that to the first row, those numbers match. That's because both of these elements are in the first column. So we're using the first column numbers to get those answers. So these second numbers are always going to match the numbers right above. So if we move on to row 2, column 2, it's going to be 7 times 0 and 2 times 1, because we're just bringing down those numbers. Okay, then we've got 7 times -1 plus 2 times 4. 7 times 2 plus 2 times -1. Okay, questions about that? I know it's a little bit complicated. The more that you do it and you understand the patterns that you can use to your advantage, it'll become a lot easier. Okay, just know that the first numbers in both of your products are going to match the entire row through. just like 1 and -3, 1 and -3, 1 and -3, 1 and -3. That comes from this first row. Then we're using the second row numbers in our second row, so 7 and 2 should be the first numbers all the way in that second row. Each column should have matching second numbers. So these ones match, 3s, 0s, 1s, -1, 4, 2, and -1. Okay, then all that's left to do is do that math. 1 times 1 is 1, -3 times 3 is -9. Let's go ahead and just take that step by step. So we've got 1 plus -9. 1 times 0 is 0. -3 times 1 is -3. 1 times -1 is -1, plus -3 times 4, which is -12. 1 times 2 is 2, plus -3 times -1, which is +3. In the second row, we have 7 times 1, plus 2 times 3, so 7 plus 6. 7 times 0 is 0, plus 2 times 1, which is 2. 7 times -1 is -7, plus 2 times 4, which is 8. 7 times 2 is 14, plus 2 times -1, which is -2. Okay, maybe once you guys get used to working these problems, you can skip this step, and that's fine. Just make sure that you don't make unnecessary mistakes by skipping it. If you have to write it out, then do that. Okay, 1 plus -9 is -8. 0 plus -3 is -3. -1 plus -12 is -13. 2 plus 3 is 5. The second row, 7 plus 6 is 13. 0 plus 2 is 2. -7 plus 8 is 1. And 14 plus -2 is 12. There's our answer. Questions? Okay, I'm gonna do one more. I'm gonna show you guys kind of a different way to set up the problem. Nothing about how we work the problem changes, but it's just kind of a helpful setup tool. Okay, here's our first matrix. It's a 2 by 2. The second matrix is going to be a 2 by 4, but I'm going to write it above this one, and I'm going to space out my columns. So we have a 2 by 2 matrix times a 2 by 4 matrix. The inner numbers match. So this is the same, almost the exact same problem that we just worked, a 2 by 2 times a 2 by 4. I've just set it up differently. So what's going to happen is our answer is going to fit right in this empty section.
Can I search?
Okay, so the way that I think this helps is that whatever number we're working on currently, so like if we're looking at what number is going to go in this first row, first column, these numbers, this row and this column is feeding right into it. So it kind of shows you which numbers for sure you're going to be using to do this product sum. Okay, so to find this number, we're using the row and the column that are feeding into it. 2, -4, and 2, +4. So we do 2 times 2 plus -4 times +4. The first numbers in each of these multiplied together, the second numbers multiplied together, and then we add those products. Okay, so now if we're looking at the first row, second column, the first row numbers are still feeding into it, but now we're using the second column from this matrix. We're going to multiply the first numbers together, so 2 times 1 plus -4 times 2. Okay, the next number, we're in the first row still, so we're still using this first row, 2 and -4, but now we're using the third column. So we have 2 times -2 plus -4 times 3. So again, we can notice the pattern. 2 and -4 are the numbers that come first in each one of these products. 2 and -4, 2 and -4, 2 and -4. That's because we're using this first row for each one of these. The second numbers are coming from the columns that are right above it. So first row, fourth column, we have 2 times 0 plus -4 times -3. Okay, second row. So now we're using 6 and 1, and then we're going to use each column as we go. So we have 6 times 2 plus 1 times 4. The 6 and 1 from this row, and the 2 and 4 from this column. Okay, then we have 6 times 1 plus 1 times 2. So again, this 6 and this 1 come from this row, and this 1 and 2 come from this column. Next, we have 6 times -2 plus 1 times 3. So 6 and 1 from this row, -2 and 3 from this column. Last one, 6 times 0 plus 1 times -3. So again, we can notice the first numbers in this entire row should match this row, 6 and 1. We have 6 and 1, 6 and 1, 6 and 1, 6 and 1. The second numbers should match these columns, which would also match the second numbers in the first row that we just did. So these 2s, 4s, 1s, 2s, all of these numbers should match. So that's kind of a way that you can check yourself to make sure you're going to get the right answer. Okay, so I'm going to try to skip that step that I told you guys you could skip eventually. We've got 2 times 2 is 4, -4 times 4 is -16. So we get negative 12 when we add those. 2 times 1 is 2, negative 4 times 2 is negative 8. So we get negative 6. And we've got negative 4 plus negative 12 to get negative 16. And 0 plus 12, we get 12. Second row, we've got 12 plus 4 to get 16. 6 plus 2 to get 8. Negative 12 plus 3 to get negative 9. And 0 plus negative 3, we get negative 3. Questions? Anybody?
This was actually easier than I